Hi everyone, so we are delving a little bit deeper into trigonometric proofs. So just a little bit of helpful information. Again, when you are asked to prove an identity and you have two sides to your equation, you're going to want to pick one side and only work with that side. It can be really tempting to manipulate both sides of your equation, but it's really easy to kind of break math, do something stupid, and then you just end up with a bad proof. So just be careful about that. It's always going to work if you only manipulate one side. And that's kind of the fun of it. That's kind of the puzzle. I really enjoy doing these types of things. Hopefully you'll find some enjoyment with it. I know it can be really tedious and stressful. So if you get stuck, just take a step back, take a deep breath, and then a lot of times starting from scratch really helps in terms of getting unstuck with some of these problems. So some of the techniques that we're going to talk about are, again, just algebraic things. So adding fractions, factoring something, multiplying by a clever form of 1, so meaning like a sine over sine or a cosine over cosine, or just any obvious algebra. In terms of trigonometric things, we will use our Pythagorean identity a lot, make substitutions, some of these things, so using your reciprocal identity, anything that will lead to a simplification are typically going to be good things. Or if you can make a substitution, that will typically be a good thing. So we will talk about different strategies. The strategies that I want you to keep in mind, though, going forward are first rewriting in terms of sine and cosine. Okay. Second strategy is to make any substitutions, to use your Pythagorean identity. My third strategy is going to be to combine fractions. So we worked a little bit with that in the past. So if you can combine fractions, that's typically a good thing. And the fourth thing is going to be to multiply by the conjugate. Now, when to do this is a little tricky, a little subjective, but if you see, for instance, like a 1 plus sine, in some case, it can be beneficial to multiply maybe by a 1 minus sine over 1 minus sine. And the reason why we would do this is because now I'll end up with a 1 minus sine squared in the numerator, and so then I can substitute and use my Pythagorean identity. Right, so that's when you might try that, but again, you kind of got to play with it and see what works when. Okay, so let's just do a few examples together, and then I will leave the rest of this up to you to do. So the first step that I'm going to do is pick a side to be my goal, and again, typically I will pick the side with less stuff. So in this case, tangent squared is going to be my goal, and on the left I see I have secant times secant minus cosine of x. Okay, so we can rewrite everything in terms of sine and cosine. That's usually the first thing that I would do, but I see that if I multiply secant in, I'll end up with secant squared minus secant times cosine, which is 1. So that's a good thing. Now, I recognize that secant squared of x minus 1 is my Pythagorean identity, so I can straight substitute tangent squared in, and I have now reached my goal. So I'm done. Okay, so these are the types of things that we're looking for. Again, you'll never go wrong rewriting everything in terms of sine and cosine, but it might just be an extra step that you don't need, so it's kind of up to you. Okay, let's go ahead and work number 2. So, very similar situation. I see that when I multiply, I'll have sine times cosecant, and so that will cancel out. So I'm going to go ahead and distribute. I'll get 1 minus sine squared of x is equal to, and again, this is my goal. 1 minus sine squared is cosine squared. Again, that's my Pythagorean identity. And so I have reached my goal and I am done. Okay, I'm just going to do one more with you guys, so let's look at number 3. So first I see 1 on the right side, so I'll say that that is my goal. On the left side, this is what I have. Now, this is kind of the opposite of some of the problems that we just did together, so I see that both of my terms here have a cosecant squared. So let's just see what happens if I factor that out. Okay, so now some things have cleared up. I see that I have a 1 minus cosine squared, which, using my Pythagorean identity, is the same thing as sine squared of x. I know that cosecant times sine is 1 because they're reciprocals of each other, and the fact that it's a squared doesn't matter, 1 squared is 1. So I'll end up with a 1 equals 1. I have reached my goal, so I have completed my proof. Alright, so those are some of the things that we're looking for. Go ahead and try the rest of this just to see, get some practice with these problems. Okay, so again, if you have any questions, just let me know, but that's it for today.